Welcome to the video tutorial series of SIMPOW. In this video we will guide you through an additional exercise on small signal stability analysis in SIMPOW. In particular, we will study the effect of a power system stabilizer on the small signal stability of a power system. First, we open SIMPOW. Secondly, start OptPow and perform a power flow calculation using the file kurs.optpow. Close OptPow and start SIMPOW instead. Load the power flow result and the SIMPOW file. We need to make some changes to the SIMPOW file, so open it in the default text editor. First, we change the simulation time to 35 seconds by adjusting the tend parameter. Next, we define a 3-phase to ground fault at bus 8. Finally, we change the run instruction to include connection and disconnection of the fault as well as disconnection of the transmission line. With the changes done, we save the file as kurs_without_pss.simpow and close the text editor. Select the new SIMPOW file in SIMPOW as well as the DINPOST file pss_study.dinpost from additional files. It is now time to run the simulation. When the simulation has stopped, open the predefined diagram which shows the active power output from generator 1. As can be seen, there are heavy power oscillations which are initiated by the fault as well as the disconnection of the transmission line. This concludes task 1. In the next task, we will add a power system stabilizer in order to damp the power oscillations. Go to the working directory. Copy the used SIMPOW file and rename it to kurs_with_pss.simpow. We open the new SIMPOW file and go to Regulators, where we add a power system stabilizer according to the exercise sheet. In order to use the new power system stabilizer, the exciter must be modified to include the parameter SWS, which should equal the identification number of the previously added power system stabilizer. Save the file and close the text editor. Load the new file in SIMPOW and run the simulation. Study the active power output from generator 1. In order to clearly see the difference between the two cases, we will plot them together in a single diagram in the next task. Go back to the SIMPOW main window, then click Dynamic Simulation, Examine Result. Load the results file from the case without Power System Stabilizer by clicking on File, select Dynamic Result File. Select the previously used DynPost file as well and click File, Go. Plot the diagram to view the result from the first simulation without Power System Stabilizer. Then load the result file from the simulation with Power System Stabilizer by clicking on File, Load New Result File and selecting it. Right-click on Diagram 1 in the diagram list and select Update. The diagram now contains the active power output of generator 1 from both simulations, so that the effect of the Power System Stabilizer can be investigated. As can be seen, the oscillation is better damped with the Power System Stabilizer than without. With better tuning, the damping can be increased further. This concludes Task 3. Task 4 to 6 are about determining eigenvalues, performing modal analysis and calculating participation factors. How to do this is covered in the previous tutorial video on small signal stability, exercise 3, and will not be repeated here again. This concludes this video tutorial. Thank you for watching this video.